Have you ever really stopped to think about what's happening inside your body when you have a drink? It feels pretty straightforward, but the science behind it is actually, well, it's incredible. We're about to go on a journey following one single molecule of alcohol to see exactly how it pulls off the feeling we call being drunk.
So this is the big question, right? How can one tiny, simple-looking molecule cause such a massive range of effects? We're talking everything from feeling on top of the world to, not being able to walk in a straight line. It really all comes down to its size and its knack for messing with our body's master control system, the brain.
So let's meet our main character, ethanol. This little guy is the active ingredient in any alcoholic drink you can think of. And its real power? It's just how simple it is. Because it's so tiny, it can slip through cell membranes like a ghost, getting into pretty much every nook and cranny of our body. And that's exactly why its effects are so widespread.
All right, so to really get a handle on its power, we're going to follow it. We're going to see its adventure through the body, step by step.
By basically putting a tracker on a single ethanol molecule from the moment you take that first sip, we can see exactly what it does at each stop along the way. You ready? Let's trace the path.
Okay, so our molecule's trip kicks off in the digestive system, but from there, it's a high-speed race through your bloodstream headed straight for some of the body's most important real estate.
Here's the basic roadmap. First, it lands in the stomach. Then, it gets absorbed into the blood. After that, it makes a super important pit stop at the liver to get processed. And finally, it arrives at its main destination, the brain. Every single stage of this trip is absolutely crucial.
And get this, that first stop in the stomach is a total game changer. Let's say you've eaten a big meal. A little valve in your stomach closes, trapping the alcohol there for a while. The result of that? The amount of alcohol that actually makes it to your blood could be just 1/4 of what it would be if you drank on an empty stomach. It's why having a meal beforehand can make such a huge difference.
Next up, the liver, the body's master filtration plant. It's got this cool two-step process to deal with the alcohol. First, an enzyme called ADH turns it into a pretty toxic substance. But don't worry, because right away, a second enzyme, ALDH, swoops in and converts that toxin into something totally harmless. This whole first pass through the liver is critical. It's what decides how much pure ethanol actually gets to the brain. And now, we've reached the climax of our journey, the brain. This is where that little ethanol molecule does its most famous work. This is where it actually creates the feeling of being drunk. The main thing to remember here is that alcohol is a depressant. It gets in the way of the brain's normal chatter. So, think of your brain as having a gas pedal and a brake. What alcohol does is it basically slams on the brake, a chemical called GABA, and at the same time it eases up on the gas, which is called glutamate. The result? Everything slows down. Brain activity is reduced, and that's where that feeling of relaxation and sedation comes from. But hey, it's not just about slowing things down. Alcohol also pulls the levers on our pleasure chemicals. It triggers a little squirt of dopamine in the brain's reward center, which gives you that surge of pleasure. And it also gets neurons to release endorphins, which are our body's own natural painkillers and calming agents. That 1-2 punch is what creates that classic feeling of euphoria. So that's the universal journey of the molecule, more or less. But here's where the plot thickens. Why does this same journey affect everyone so differently? The same drink can make one person feel amazing and another person feel just awful. Let's dig into why that is. While one of the biggest factors is simply body composition. So even if a man and a woman weigh the exact same, they're probably going to have a different blood alcohol concentration. In general, women tend to have a higher percentage of body fat, which needs less blood than muscle. So with a smaller total volume of blood to dilute the same amount of alcohol, the concentration just gets higher, faster. And the result is pretty clear. If you have the same number of drinks and the same body weight, a woman's blood alcohol concentration, or BAC, is typically going to be higher. It's just a matter of dilution, really. The same amount of alcohol in less liquid means a stronger drink, so to speak.
But beyond just body composition, our own DNA plays a huge part. Some of us have genetic quirks in those liver enzymes, ADH and ALDH, which affects how fast we can process alcohol. Others have different sensitivities in their brain's reward system. These genetic differences can influence everything from how a drink makes you feel in the moment to your long-term risk of developing a use disorder.
And that brings us to the final chapter of our story. What happens when this journey gets repeated over and over again? Well, the body, and especially the brain, is incredibly adaptive. And it definitely adapts to the constant presence of alcohol in some really powerful ways.
With chronic use, the brain starts to fight back. It begins to produce fewer of its own feel-good chemicals like GABA and dopamine because it's gotten so used to alcohol providing them instead. This creates a whole new normal. So when that person is sober, they actually feel uncomfortable, which can kick off a vicious cycle of drinking just to feel normal again.
And this is the direct fallout from that brain adaptation. Regular drinkers might start to feel anxious, have a hard time sleeping, or just find that they're getting less pleasure out of everyday life. Their brain has fundamentally rewired itself to expect ethanol to be there.
So in the end, it all really boils down to this. Your personal experience with alcohol is a unique cocktail of your genetic lottery and your personal history with it. It's a perfect case of nature and nurture working together.
So, from that first sip all the way to long-term changes in the brain, that's the journey of ethanol. It's a remarkably simple molecule that sets off this cascade of incredibly complex events in our bodies. Now that you know the whole story, from the liver's chemistry to the brain's delicate balancing act, what's the one thing that really stands out to you?